Dave, have you seen my glasses? By the way, it's a good reason to talk about more last night. Probably.
All right, good. All right. That's why, because they didn't. Yes, I should have. All right. Nope. did send it. Hi, Kaylin. Be there in a second. Have to get the lighting correct. How you doing? Kaylin? Kaylin? Did you just pop in and then pop out again? Kaylin? Okay. Hi, Chase. Oh, still connecting. Hi, Chase.
Hello, how are you?
I'm doing fine. Are you doing okay on everything?
Yeah, I think so.
Good enough. Good enough. How are you doing on these quizzes?
I'm doing pretty good on the quizzes, but for
Good.
some reason, I don't know what happened, but I emailed you about it. It was the issue with the book.
The book.
Yeah, it was like disappeared on me for a solid day almost
Oh, the book in Intro to,
to do the homework.
oh, the actual access to the online book.
Yeah,
Yeah, that's something you have to figure out with them because I have no idea what's
yeah,
going
I
on.
I figured it out, but
Oh, good.
I had
Hey,
to
I'm
start
happy
from
that you
scratch.
figured it out.
Yep.
No, do not yawn. It's a
That wasn't
contagion.
a that wasn't a yawn, sir.
That wasn't a
No,
yawn? Yeah, but don't even think about yawning because uh, it's just the way life goes, you know?
been a long day.
Yeah, absolutely. And I got 2 more classes to get through. Are you in the last one or are you done after this?
I'm done after this.
Oh, good for you. Good for you. Yeah, that's the, I only
Yeah,
have one more class to get into my grade book.
I've got classes from 11 to 6:45 with like an hour break between each of them. So it's kind of nice, but at the same time,
So what
today
did
is
you
like
plan on for what did you plan on for Monday and Wednesday? Do you have anything going on then?
Monday I only have my English class, my comp class I mean, and
Uh-huh.
then Wednesday I don't have any classes, but Tuesday I have algebra and your class. And then on
It's how many,
Thursday
what are you
I
getting,
have
about 17 hours, 15, 16 hours?
I think so.
Mm. So how much more, how much longer do you have to go to this before you get on?
This is only my second semester, if that's what you mean.
Yeah, so you're gonna go this whole 2 years, get
Yeah,
your AA. That's
yeah. I'm gonna
smart. I mean,
get my AA and then transfer to USF.
okay, good for you. Good for you. And I gotta find out, there it is. Uh, yeah, it's, oh, I have more people here. Uh, yeah, I've actually got Kaylin, but I think she buggered off on me.
I'm here now.
You're
You're
here
right.
now?
I
Where
did
did you
press the button
go?
and walk away. You are correct.
Ah. So Chase, what are you getting into? What are you gonna major in?
Biomedical sciences.
Good for
Right
you.
now, I'm doing it, and so next semester in fall, I'm gonna be doing EMT school and then like 2 classes, so I can get patient care hours to apply to PA school once I graduate from USF.
Oh, good. That's good. So you're gonna be taking classes at Park and 66?
Yes, sir.
Okay, good for you. Good for you. Kaylin, what are you planning on doing when you grow up?
Oh boy. I applied to nursing school last term, got in, and then decided I didn't want to do that anymore.
Something to have to do with COVID?
No, I just realized I didn't think I wanted to be hands-on patient care, so I'm gonna do medical laboratory science
Patients are
instead.
horrible.
Yeah, I was a server for like 10 years. I think I've had enough with people.
For that. Serving's not fun.
No, it's awful.
I actually served in a retirement facility, so it's even more wonderful.
Oh,
hmm
so you get to wipe my butt in about 10 years, huh?
No, that wasn't me. No, but I did have to move the dining room chair that would have happened on.
Uh-huh. Okay, depends. Wonderful stuff. So Jennifer, what are you going to get into? I take it nobody has anything they really want to talk about.
Well, I have two goals, a short term and a long term. So my short term, I want to become a middle school science teacher, and then long term is elementary
Are
music.
you insane?
No, I love math, and I thought of math too, but I'm like, I actually like science more than I do.
Jennifer, ninth graders should be caged and let out when they're 45.
Middle school, so it's even worse.
Yeah, ninth grader. Yeah. Ninth
Sixth-
graders do not have an off switch. I taught ninth grade 1 year in Pasco High.
Mm,
That was
I
enough.
remember a little bit younger, about sixth grade to eighth grade.
That's actually the age of my granddaughter. My grandson is sophomore. My granddaughter is just about that age right now. I think she's in eighth grade.
Nice, that's good.
No, it's not. I just want to give her an injection at her age her about 5 years.
That takes time, unfortunately.
No. Just give me the injection. That will work. Chase, when you're biomedical research, this is something you need to look into. I don't want them to age constantly. Just they can stop when you age them to about 18 or 19. Then they're functional again. Hunter, what?
I have a question.
Yes. Okay, Hunter. What? Serious.
How are you doing today?
Was that your question?
Yeah.
I can answer that one. What do you got?
I'm looking at the lab report for density and miscibility. And, oh, by the way, don't be mad at me, but last night I think I kind of sucked on the other lab report, but we'll see what happens.
You did what?
I don't think I did great on the other one, but I don't know why.
You got an 83 on the first lab report.
No, I know, but on this other one, I was up like really late and I was kind of just like delirious. So like, I don't know, just we'll see what happens with that. But on this one, I have a question.
Wait, time out. You've only submitted one, and the density is the second one.
No, the next one. Which one's the next one is mass and volume.
Oh, my bad.
Yeah.
My bad.
On mass and volume, I don't think I did that great.
No. My bad. I'm thinking in terms of 2045.
That's okay.
You're right. So you had the chem and physical properties, then you had the mass and volume. Okay.
Yeah. So I'm actually looking at so you know how if you have like a beaker and let's say it's going from 4 to 5, there's 4 notches in between, right? How do I count? Like how many decimal places or
There's
like
4 lines. There's 4 lines, right? All right. So you're going from 4 to 5, and there are 4 lines in between, right?
Yeah.
Andrew. So there are 5 spaces, right?
Yeah.
So you divide the 1 by 5. So each line is worth 0.2.
2, 4, 6, 8. Okay, that makes a lot of sense because I'm looking at one where liquid A is at 4 and then it's at the second notch, so that would be 4.4.
Correct.
Okay.
You cannot estimate any further than that.
That makes sense.
You can't estimate any further because what you're estimating, all right, if it's between the lines, you're going to call it the odd number.
Yep.
Like if it's between the second and the third line, you're going to call that 4.3.
Yep.
All right. So that's what your estimation is. You can't go any further out to the right. That is your estimation. So when you're reading that particular graduated cylinder, it only goes out to the tenths.
Okay, and then just to clarify, I know this is kind of basic, but on the third slide on a triple beam balance, the 10 gram scale, you measure that like, let's say it's halfway in the middle between 2 and 3, that's 2.5. And then
Okay,
each
wait.
notch.
All right, I need to clarify this. All right, are we talking about the balance arm that moves at 10 grams at a time?
Yes.
All right, Those are 10
No,
grams.
no, 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 no. I'm sorry. I'm talking about the smallest.
The slide one, the one that
Yes.
slides, and it's from 1 to 10, marked off in 1
Yes.
gram integrams, right?
Sure.
All right, so you have 1 gram 1 gram space. Sorry, I'm
Interval?
having a hard time describing
No,
this. Okay, you have
don't
2 lines that are marked with numbers, right? Say you have the 3 and the 4. Now, between the 3 and the 4, there are 9 lines or 10 spaces.
Yep.
That means that
spaces.
each little tick is worth 1/10 of a gram.
That's 0.1, right?
Correct.
Okay.
That's what you know.
That's fine.
Now, wait, but Hunter, you have to estimate to the hundredths. That one you have to estimate to the hundredths.
So if previously I had like 33.9, it's 33.90.
Correct. Yes.
Wow. Okay. Yeah, I screwed the pooch last night.
All right. Sorry.
We'll see. We'll see what happens.
We'll see what happens, Hunter. Don't worry. It's going to all shuffle out at the end. Anybody else have anything else they need to talk about? We were having a fine conversation until Hunter had to break it up with something
Yeah.
technical.
I'm sorry.
No, you're not.
You're right.
Good for you. Good. Absolutely. Everybody's doing fine, correct?
Yes,
I don't have-
sir.
I don't have to talk anybody off the ledge yet, right?
Not yet.
All right. We're going to keep you. We're going to keep you in so that you're within arm's length so I can grab you if I need be. All right.
You got it.
All right. We're going to get through this thing. We're going to get through this semester. I got 1 more minute. Anybody have anything about what we talked about yesterday, the structure of the atom and the valence electrons? Because in about less than a minute, I'm going to be showing my favorite video of all time. It's the 2 dogs again. The honest to God, I really, really wish this lady would have gone off and done a whole bunch of things with these dogs because they work. They work very, very much. All right. So I'm going to need somebody to tell me right away whether or not the video is, you can hear the video. All right. Sorry, I'm just trying to get people in.
I can't hear the video.
I haven't turned it on yet. I'm trying to get people. I go to put the video on and people keep trying to jump in and join. And there comes Helen in. So you guys get to yell at these people for coming in at the last second. Here comes the video. Can you hear it?
Welcome to Dogs Teaching Chemistry.
Yes.
Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by 2 atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
I ask you, can you point that out in any better way?
No.
No, I don't want to end the meeting. Oh, there, that's a, Andrew, is it Omar? Who's dressed up like a scarecrow?
I'm here.
Who's dressed up like, is that you, Omar? A dead person?
I don't have my camera on. It's off.
Yeah, he looks kind of like stiff, man.
Yeah, it's almost look like a dead person or a walking
like
dead.
camera is
Like
off.
a dead clown or something. I don't
A
know.
dead clown?
My
Looks
camera's
like
off.
he looks like a snitch, sir.
A snitch?
Yes, sir.
Okay, we're going to get back into valence electrons. Now, just a little bit of review of what was going on last week, on Tuesday. The valence electrons, they're the ones that we need to be worried about. They're the ones that actually get involved in bonding. All right. If an atom has 3 or less electrons, they are going to lose them. Remember putting the kids on the church steps, guys? If an atom has 3 or less electrons, they're going to give them up. When they give those electrons up, they are going to be positively charged. All right. On the other hand, we have other atoms that have 5 or more. What they're going to want to do is they're going to want to get electrons until they get 8. So something like nitrogen that has 5.
Hey, Professor.
I'm sorry, Gaith? Were you just saying hello, Gaith? All right, nitrogen has 5 electrons. That means to fill that shell up, it can get 3 more. So it's going to get those 3 extra electrons. So we now have something that is positively charged and something that is negatively charged. All right, do you have your periodic tables out? I think this may have been where we left off.
Yeah, I got it.
All right. Do you remember I told you to mark the periodic tables? First column +1, second column +2. Do you recall my saying that?
Yes.
Okay. I want you to find, Hunter, I want you to find bromine.
Where's that again?
Look down from fluorine.
Okay, I see it.
So which column is that in?
That's in 17.
Okay. Remember what I told you to mark it.
-1.
So what's the charge in bromine? You can say it. Don't stop yourself. Andrew.
What do you?
Oh, remember I told you, you labeled those columns that because of everything below it has that charge.
Yeah,
Okay, so what's the charge on bromine?
-1, right?
-1. It has 7 electrons in its outer shell. It
Yeah.
can grab 1 more, so it can have a -1 charge. All right, Gabe,
Yes, sir.
did you mark your periodic table?
To be honest, I did not.
Okay. All right, I'm gonna
sorry.
get on to somebody else. Omar,
Yes,
did you mark your periodic table?
I didn't have one, unfortunately, but I
All
can download one online. I ordered one from Amazon. It takes a
All
week
right,
to
there's
arrive.
another way. There's another. Do you have a periodic table right now, Omar?
No.
Come on, download one.
Okay, I will.
There's one in the course. Download it. Terry, you have a periodic table, Terry?
Yes, sir.
All right, I want you to find oxygen. Everybody else, play along with Terry. I want you to find oxygen, Terry.
All right, I got it, sir.
All right, how many places can you move over to the right?
2.
That means that oxygen can grab 2 more electrons. So if it does grab those 2 electrons, what's its charge going to be?
-2.
-2. Let's see. Faye, you out there, Faye?
Yes, I'm here.
All right, nitrogen.
Mm-hmm.
How many places over can you, how many spaces, how many blocks over can you move from nitrogen before you get to the end?
3.
3. That means nitrogen can get 3 more electrons. If it gets 3 more electrons, what's the charge on nitrogen?
-3.
Are you seeing, guys, how this works? This
Can
is
we get a
not-
visual representation for the?
Yes. Go find the periodic table. All right, now we have to talk about different types of chemical bonding. And basically, a chemical bond is nothing more than the force that holds 2 atoms together. And we have 2 different types. We have ionic and we have covalent. Now, it's basically, it's like thinking of communism versus capitalism. Now, if we're thinking about communism, the
Oh, here we go.
true communism, it's basically an economic system in which everybody throws everything into a pot and you only pick out of the pot what you need. Everything is shared. So we can think of covalent as being the same thing. When we have covalent, that's an electrical system in which the electrons are shared. If you have water, water has 1 oxygen and 2 hydrogens. Oxygen isn't powerful enough to grab the electrons from hydrogen. It can only share them. So the electron spends some time on the oxygen, then a little time on the hydrogen. More time on the oxygen, little time on the hydrogen. So they're sharing the electrons. Covalent, sharing electrons. If you look at a periodic table, all the elements that are to the right and above the little stair step thing, all those elements are non-metallics, non-metals. If you have a non-metal, it can bond with another non-metal and form a covalent bond. So covalent bonds are just formed from that side of the periodic table. Now, some of the elements that are on that side of the table cannot exist alone. They're afraid. They're very, very afraid. They don't want to be out in this cold, cruel world by themselves. So what they do is they bond with another one of their own. You will never see one hydrogen atom out there floating alone by itself. It will always latch on to another hydrogen. You will never see one chlorine. It's going to find another chlorine and bond together and covalently to have a molecule. Chlorines will not exist as one chlorine atom. There's a mnemonic for them. Have no fear of ice cold beer. Have hydrogen. No nitrogen. fear, fluorine, of, oxygen, ice, iodine, cold, chlorine, beer, bromine. These are the 7 diatomics. They exist. If you ever see them anywhere in a chemical equation or anything, if you see them just as H, that is wrong. It has to be H with the subscript 2. There have to be 2 of them together. On the other hand, if we don't have communism, we have capitalism. And capitalism is an economic system which says what's mine is mine and what's yours is mine too. It's whatever I can grab. That is like ionic. When we have ionic bonds, what happens is one of the atoms has enough power that it can grab the electrons off the other. When it grabs the electrons, it becomes negatively charged. The other atom lost electrons, so it's now positively charged. Positive and negative attract. We have an ionic bond. Yeah, I've already gone through this. Now, how do we know? How do we know whether it's going to be an ionic bond or if it's going to be a covalent bond? There is something called electronegativity, and it's a relative numerical value which suggests how much an electron is attracted to an element. Okay, so what you're going to look at is you're going to look at the electronegativities between the 2 atoms. If the difference in electronegativities is greater than 2, that means that the one atom has enough power to grab the electrons from the other. If the electronegativity difference is between 0.3 and 1.9, there's not enough. One is not powerful enough to take the electrons from the other. So they share the electrons. But when they share them unequally. The one that has the atom that has the greater electronegativity holds on to the electrons for a greater time than the other one. So the one that holds on to the electrons more has a slight negative charge. The ones that hold on to the electrons less have a slight positive charge. If you get differences that are almost equal, then you have a non-polar covalent bond. There's little or no difference in the electronegativity, so it's going to be a non-polar bond. They're controlling the electrons equally. Generally speaking, when we're dealing with ionic bonds, we're looking at metals and nonmetals. If your periodic table
What's up,
has,
baby? How you doing? I just got off work.
look at your periodic table.
Mhm.
Does it have a staircase in it that starts at between boron and aluminum? Is there like a thick line there? If not, I want you to draw one. I want you to draw a line between boron and aluminum, between B and Al, between aluminum and silicon, Al and Si, between Si and germanium, Ge, between germanium and arsenic, As, between arsenic and antimony, Sb, between antimony and tellurium, Te, then between tellurium and polonium, and between polonium and adenine. I want you to draw that staircase if one is not in your periodic table right now.
The periodic table I have has the staircase 1 block higher than the elements you listed.
It starts
Wait.
with,
Go ahead.
it starts with between boron and carbon.
That's what I have on my periodic table, but I got a color-coded one off the internet.
Okay. What you may be doing is they may be defining the non-metals. Carbon is definitely a non-metal. It is not, should not be right at the staircase.
Okay, I'll change it then. Thank you.
Hey,
So-
does mine have the staircase here?
No.
Damn it.
So you're gonna go between B and AL.
Okay.
Draw a horizontal line between B and AL, between AL and SI, between SI and GE, GE and AS, AS and SB, SB and TE, TE and PO, PO and AT. That should be your staircase.
Okay, so
Everything,
it's like shaping up here. Hold on.
we're gonna get into this later when we talk into periodic trends, which hopefully later today. I'm sorry, you got it. You got
right.
it.
Thank you.
Okay, everything to the left of that staircase is a metal. Everything to the left of the staircase is a metal. I'm being very generic right now. Everything to the right of the staircase is a non-metal. When you have ionic bonds, that is an electronegative difference of 2 or greater. What that means is that you have a metal, something that's to the left of the staircase, linked with something to the right of the staircase. That is what makes an ionic bond. Now, when you have a covalent bond, you have one nonmetal, one of the atoms to the right of the staircase, hooking up with another one to the right of the staircase. You have 2 nonmetals. Questions, guys?
You know what I was thinking? Couldn't you never mind. You know what? It'll take too much time to talk about. Let's go on to the next thing.
Talk to me, Hunter. It may work it out for other people.
No, it's not. It's just some nonsense that I'm thinking about. But no, I was gonna say when they first started discovering elements, couldn't they have predicted the existence of other elements just knowing certain aspects of the mass and electron and proton number?
When we get into the periodic table, as a matter of fact, you're absolutely right. Germanium, GE. When Mendeleev made the periodic table, germanium didn't exist. So Mendeleev put a hole in the periodic table. And later on, they discovered it and put it in the hole. So he basically predicted that there would be an element here. It just wasn't known to exist.
Is that still possible?
No, because right now, Hunter, we are actually, they have filled out the bottom row of the periodic table. They're all the way up to 118, which it gets you to a noble gas. All right. And these things only exist very, 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 very limited time.
Oh yeah, you said that before. All right. Anyway, let's get on to the next thing. I'm sorry.
I got to figure out what that is. Let's go with it. We're going to go from valence electrons. We're going to start to talk about the periodic table. And what I'm going to need you to know about the periodic table are some areas you're going to need to be able to identify. what certain areas of the periodic table define. You're going to be able to, at the end of this, you're going to learn periodic trends, and then we're going to start to get into chemical formulas. Dimitri Mendeleev, another one of these guys, you're responsible for knowing what he did. This guy is a friggin' genius. Look at the periodic table. Does it make any sense to you? It goes up on the left, it goes up on the right, looks somewhat like a castle. It goes down in the middle, and God knows what those two rows at the very bottom are for. Mendeleev predicted, was able to organize all the chemicals. And the way he did it was he started to group things according to their properties. He figured out, okay, if I put sodium and chlorine together, there's one sodium that links with one chlorine. All right. If I stick bromine with sodium, there's only one bromine with every one sodium. That seems like I should group sodium and bromine together. On the other hand, if I have magnesium with chlorine, I'm going to need two chlorines. So I'm going to have to put magnesium into another row. Basically, this is how he was going about trying to organize the periodic table. He was able to put things that weighed more lower than things that weighed less. And it was just in the middle of the 19th century, around the 1870s or 80s, somewhere in there, that Mendeleev was able to actually come up with his table. Now, you guys have some Roman numerals at the top here, and your Roman numerals probably differ from these ones. I'm going to call the columns that go up from the middle here, all these columns that go up from the middle, I'm going to call those the representative elements. And you can label them, just like I told you to do the other day. 1, 2, 3, 4, 5, 6, 7, 8. And what that stands for is, that stands for the number of valence electrons that those elements possess. Everything in column 1 has 1 valence electron. Everything in column 6 has 6 valence electrons. And you can use this to determine how many electrons they're going to gain or how many electrons they're going to lose. If, for example, I am in sulfur, sulfur has 1, 2, 3, 4, 5, 6. It can hold 2 more electrons. So it's going to gain 2. Other areas, the trough area, the bottom of the pool, whatever you want to call this area. These are called the transition elements. The ones on the very bottom rows here are called the F transition elements. Top row are called the lanthanides because they follow lanthanides. The bottom row are called actinides because they follow actinide. Questions so far? All right. If we're looking at vertical columns, because they all have the same number of electrons, they're all going to act the same, and they are called families. If it's in a column, the elements are going to act the same. These are called families. If we're talking about the rows are called periods. 1 second, guys. Hello. No, you can't. Bye. Sorry. Somebody wanted to speak to Gregory. Okay, so columns, families, rows, periods. Different families have different names. The first column are called the alkali metals or the alkaline metals. I believe I call them alkaline. Second column in are called the alkaline earth metals. The second column from the right are all called halogens. The furthest column to the right are all called noble gases. In the bottom two rows, top row are called the lanthanides, bottom row are called the actinides. And you remember I told you about that staircase. Now, the staircase indicates that along where the staircase is are the metalloids. Apparently, I drew it wrong before. I'm sorry, guys. It goes below aluminum, down to germanium, between tin and... No, that's wrong. This is wrong. It's the way I drew it
Professor?
before. It's the way I drew it before. Yes.
It looks like you just have to move the image down.
Oh,
Like it's just not aligned right. You see it?
what? No, oh, are you saying? I think I see what you're saying. Thank you, Christina. That makes all the sense in the world.
You're welcome.
When I described it before, basically, this is supposed to move up the way I described it before. Everybody clear on that? I think what happens, I'm sorry. What happened is this got moved when I was switching around one of my slides. I'm sorry. The way I described the step earlier is the way it is. All right, now, what you have to know is that the elements that are on either side of the step are called metalloids. So, with the exception of aluminum, silicon, gallium, germanium, arsenic, antimony, tellurium, polonium. Those are all metalloids. They act as both metals and nonmetals. Everything to the left and below where that staircase is, those are metals. Everything that you see in white here, those are considered nonmetals. Nonmetals, this is actually a better one. Nonmetals are here. Metalloids are what are considered in pink, and the metals are everything else over here. Notice, even though helium is over here, it's considered a non-metal. The important elements in the body, it's called chinops. Hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. Those are the ones you're going to have to deal with for some of you when you get into biochemistry. Metals, they're shiny. Metals, you can pound them. You can pull them. and metals will conduct electricity. Non-metals, as a general rule, have a dull finish. You can't pound them. If you try and pound sulfur, you're going to get a whole lot of very fine powder. You can't pull it. They don't conduct electricity. As a matter of fact, most non-metals are insulators. And that's what, let's see if I can go back. You see that silicon is a metalloid. That means that it can conduct electricity under certain circumstances. It's this property that allows us to use it in computer chips. Okay, Faith. Lithium.
Mm-hmm.
What is it? You have a choice: alkali metal, alkali earth, non-metal, or a noble gas. What is lithium? Do you have your
Lithium-
periodic table?
Lithium is alkali metal.
Alkali metal. Alec, aluminum.
Metal.
Metal. Helium. Let's see who I'm going to bother at this point. Winifred, sorry, I'm calling HCC out. Leandre. You hear Leandre?
Yes.
Helium. Do you have your periodic table, Leandre?
Yes.
All right, where's the helium at?
Do I answer?
Yeah, go.
Isn't it a non-metal?
It's going to be a non-metal, absolutely. Phosphorus. Is Apple Grace here tonight? How about Curtis? Phosphorus. Andrew Melick.
Phosphorus? Is it alkaline?
Okay. Do you have your periodic table, Andrew?
No,
All right.
I don't have one.
Andrew, you need to get it. Okay. You
Got it.
can't answer these questions without it.
Okay.
Christina, phosphorus.
Phosphorus is a non-metal. It's a halogen.
No, it's not a halogen.
It's just a non-metal.
It's just a non-metal. A halogen would be in the next to the last column, starting the top metal, the top element will be fluorine.
Okay.
Okay. Shamira. Shamiria. Sorry, Shamira. Hi. Do you have your periodic table?
Yes,
Magnesium.
it's a, is it a alkaline earth metal?
Finest kind. Absolutely. Okay. So what I need you to know for the periodic table: 1, columns are called families, rows are called periods. You need to know the first column are the alkaline metals, second column alkaline earth. Next to this starting fluorine, then this one does not have the noble gases on it, this periodic table. Fluorine down below are considered halogens, and helium down below are considered the noble gases. You need to know that there is a step ladder going through the periodic table that defines metals from non-metals. If it's going along that ladder, silicon, germanium, arsenic, antimony, tellurium, polonium, those are considered metalloids. They have both metal and non-metal properties. Metals are to the left of that line, non-metals are to the right. Okay. Now, A lot of this stuff makes sense if you just want to think about it. Okay. Now, every time I go down a period, I make the valence electrons further out from the nucleus.
Hey, I found this online where it just like color codes. You see how it's like, you know, all the different types, and it's just kind of like color coded. Is that okay?
That's fine. As
Hey,
long
drop
as,
that link, man.
as long as it looks something like that. Hunter, do you see this slide?
Yeah, I see it, but it's and it's got like a bunch of different colors, but it's like it'll show you which ones are alkaline metals, alkaline earth, basic, transition, all the different types.
Okay. Post it, Hunter. The ideal thing for you to do would be to post that on the discussion forum. That counts as a discussion. Okay.
Okay, I'll do that.
So Professor, I'm wondering, given that there are so many different types of periodic tables that we see, some have labels, others don't. So is there a restriction in terms of which kind can we use for the exam?
I don't think I restricted anything, Rosina.
Okay, thank you.
All right. If you want to pay Livermore Laboratories, if you want to pay them for their periodic table, go for it. It would probably confuse the snot out of you, but you can buy it. All right, we're talking. Our first periodic trend is electronegativity. And as I said, it makes a lot of sense. If you think about it, every time we go down a row, we've added another orbital of electrons. Every time we add an orbital of electrons, we take it further away from the positive force. Remember, electronegativity is the ability to attract an electron. So if we go further and further down, we're getting further and further away from the positive charge. Doesn't it make sense that the ones that are down below have a smaller electronegativity? So as you go down the chart, the electronegativity decreases. Now, it's easier if you have 5 electrons, it's easier to gain 3 to get the octet. If you have 3 electrons, it's easier to lose them. So it's easier to want the electrons if you're on the right side of the periodic table. The elements that are on the right side want the electrons that much more. So as you go from left to right, electronegativities increase. As you go down, electronegativities decrease. All right. Rosina, do you have your periodic table? Rosina,
Yes, I do.
Okay,
Yeah.
good. Now, remember what I just said. Electronegativities from left to right decrease. I'm sorry, increase. Left to right,
Increases.
increase. Electronegativity decreases going from the top to the bottom.
Yes.
So I want you to find nitrogen, bismuth, and arsenic on your periodic table. Everybody else, work along with me.
Okay, I see nitrogen, bismuth, and yes. Okay, they are all in the same column.
They're all in the same column. Now, I want you to rate them. Least electronegative to most electronegative.
So Bi would be least electronegative.
Why is it the least?
Is the valence electrons are furthest away from the nucleus.
Go for it.
So Bi, As, and then N.
How do we know that they're the least, or that they're, how did you know that?
Okay, every time, Hunter, every time you go down a period, you put another orbital so that the electrons get further and further out. There's more distance between the electrons and the positive nucleus, which is the reason that the electrons are being attracted there to begin with. Hunter, makes sense?
That makes sense.
All right, good. You do the next one. Do you have your periodic table?
Oh my God. Yeah, sure. No, I got it right here.
Bromine, potassium, and copper.
Okay, let me find bromine, which is going to be right here in 17. And then you said potassium.
Bromine is not 17. Bromine should be 35.
Or 35, sorry. But it's in row 17.
Yes. Okay.
Okay.
Potassium, K.
You said K. That's all the way over here. Then row 1.
Not row 1, column 1.
Sorry, column 1. And then we have, what did you say, C?
Okay.
And that's copper, so that's going to be in column 11.
All right. But are they all in the same row?
Yeah, they're all in the same row.
What did I say about the electronegativity if you're in a row?
They're all going to be the same.
No. Do you see the slide in front of you now, Hunter?
Yeah.
What
Okay.
happens to the electronegativity as you go from left to right?
It increases.
So, which is the smallest?
The smallest is going to be potassium.
Next.
Then it's going to be copper.
Last.
Then it's going to be bromine.
There we go. Absolutely. Let's see. Jennifer, I haven't bothered you yet.
Okay.
All right. You have, yours is a little bit more difficult. You have copper, fluorine, and tin.
Okay.
Isn't that
All right.
carbon?
I'm sorry. Did I say copper? Carbon. Thank you so much. Carbon, fluorine, and tin.
And it's from least to greatest, right?
Least to greatest. Now, I'm gonna. Do you want me to lead you through this, or do you want a shot at it on your own?
No, I think I can try it.
Go for it.
So least to greatest would be tin, fluorine, and carbon.
No. All right. Look at carbon and fluorine. Are they in the same row?
Yes. Okay. So it would be tin, carbon, fluorine.
Tin is less than carbon because tin is below it in terms of period. Okay,
Yeah.
so tin is less than carbon, and carbon is less than fluorine because carbon is to the left of fluorine.
Yes. Okay, yeah, I got it now.
Aaron. Aaron, hi. You have sulfur, cesium, and indium.
Okay. Hold on, I'm looking.
Sulfur you find by oxygen. Sulfur's one down from oxygen.
So cesium, indium, and then
Good God, I gotta find indium.
and then sulfur.
Yeah, I found indium. Yeah. Okay. All right. Just to facilitate matters, sulfur is below oxygen, indium is below boron, and cesium is below hydrogen. You got them? All right. Give me your best shot.
Oh, so from the least to the greatest, it's cesium, indium, and then sulfur.
Finest kind. Indium is below and to the left of sulfur, and cesium is below and to the left of indium. So yes, you're absolutely right. Cesium is the least, indium, and then sulfur. Guys, I want you to note note on the chart. Okay. You see between, if I would ask you nitrogen and chlorine, I'm not going to. Anything that is that close, I am going to make it definitive, just like I did for Aaron a second ago. These things are going to be far enough away from one another that you're going to be able to easily tell on a test which one is greater than the other. I wouldn't give you sulfur and nitrogen, for example. Fair enough? All right, now electronegativity is the attractiveness that an element has for an electron. There is another term, and that is called ionization energy. And ionization energy is the energy needed to remove an electron from an element. In other words, it's the energy needed to make a cation. Okay? Now, let's think about this. If you have something like francium, that is 1, 2, 3, 4, 5, 6, 7 orbitals away from the, that's 7 orbitals away from the nucleus, where the positive stuff is, right? Is there that much force way out there that that electron in that valence state is feeling from the nucleus? Do you think that the valence electron in francium feels the nuclear energy more or less than lithium does, which is the next orbital out?
Less.
Less.
So if it feels it less, it's going to be easier to remove that electron. Does that make sense to you?
Yes.
All right. Now let's consider left to right. How many protons does hydrogen have? I'm sorry, how many? Lithium?
3.
3. Beryllium?
4. 4.
Okay, now the 2 electrons that are floating around beryllium are in the same orbital as the 1 electron floating around lithium. Yet, how many plus charges does the 1 electron around lithium feel? How many protons is it feeling the plus charge out of?
1.
No. How many protons are in the middle, Rosina?
3.
There are 3 protons. So that electron is feeling the effect of 3 protons, right?
Yeah.
What about beryllium?
That's 35.
No, beryllium is 4.
Oh, sorry.
2.
So beryllium has 4 protons. Now, the electrons aren't any further away, but now they're feeling the effect of 4 protons, where with lithium, they only felt the effect of 3. And you go all the way over to fluorine. Those 7 electrons that are in that orbital are feeling the effect of 9 protons. So in the case of fluorine, the electrons are feeling 9 protons as opposed to lithium that are only feeling 3. Now, Rosina, if
Yes,
you
sir.
had 9 men trying to drag you down the street,
I hope not.
would you be able to fight them off more or less than if you only had 3 trying to drag you down the street?
Well, if I didn't have any superpowers, then
Are you seeing the argument I'm making?
yeah.
Ionization energy. The ionization energy is the energy needed to take an electron away from an atom. It increases going from left to right. It increases going from bottom to top.
So when they say ionizing radiation, they mean that radiation is stripping whatever electrons away from things.
You'd have to give me the context, Hunter.
Like,
You'd have to give
I
me
don't
the
know,
context.
you always hear like in like things the term ionizing radiation. Does that mean that said ionizing radiation is taking the electrons, like let's say carbon, like in our body?
Okay. The way I'm gonna answer that is this. Radiation is a form of electromagnetic energy. Okay. So the energy taking the electron away is converted to radiation. Electromagnetic energy.
Oh, okay.
Professor P, I was wondering if this is another way to look at ionization energy, that helium, the very last column is all noble gases. So they already follow the octet rule. But then the one to the left needs only one more electron to follow the octet rule. So is that a way to analyze this as well?
Rosina, that's a perfect way to analyze electronegativity. Okay? Rosina?
Yes.
But in electronegativity, we're attracting electron. Ionization potential, we're trying to take an electron away from there.
Got it. Okay.
It takes more energy to take an electron away from fluorine than it does to take it away from lithium. That's what we're saying.
Okay.
And the reason being, it's in the same row. There are more protons hanging on to those electrons greater.
Okay. Thank you.
All right. Let's go with Maria. Maria? I'm sorry, Maria. Mariah, sorry. What I didn't do is I didn't put the emphasis on it. Mariah, all right. I need you. Do you have a periodic table?
Yes.
All right. I need you to find boron,
All
Ti,
right.
and gallium. Titanium, Ti is titanium. Oh, that's TL.
Gallium.
I'm sorry, that's TL. That's not Ti.
Oh, then I found them because
Okay, 1 second. I want to fix it.
Oh, there.
Okay. All right. You have boron, tellurium, and you have gallium. I want to know energy from lowest ionization energy to highest.
Gallium for the lowest, and then gallium, and then boron.
Why?
Because thallium's like valence electrons are farther from the nucleus.
There we go. Absolutely. Absolutely reason. Okay. Iodine, molybdenum, and silver. Cash.
Yeah.
Cash, do you have a periodic table? Cash, I'm going to let you go because your microphone sucks.
Okay.
You don't sound too brokenhearted about it. Victoria, smile at me, Victoria. See if I don't call on you. You have iodine,
Yep.
MO, molybdenum, and you have silver. You have your
From
periodic
least to
table,
hi-
Victoria.
Yes, I do. From least to greatest or least to
Least to
highest?
greatest. Least to greatest.
Would it be? Oh boy.
What do they all have in common?
Well, they're all in the same row.
Okay, now,
So would it go just however you pronounce that first one, the
molybdenum,
MO, yeah, silver and then iodine?
because they increase from left to right.
Yeah.
Molybdenum is to the left of silver, which is to the left of iodine. All right, silicon, chlorine, and lead. Katie,
Yes.
all right, silicon,
Lead. Hold on.
silicon is right below carbon. Lead is below that, several layers down. And
Chlorine.
chlorine is to the right of
Okay.
silicon.
So it would be lead, then silicon, then chlorine.
Absolutely. Absolutely. And now the last one. We are doing Brian. Brian out there?
Yes.
Okay, you have chlorine, calcium, and radon.
Where's radon at?
Radon is right below. Radon is below helium. It's an inert gas. No, I'm sorry, wrong. It's Ra.
Yeah. Ra is radium
Thank you.
in group 2. Okay.
Yeah, that's where it's at. Right beside francium.
Okay. So it'd be radium, calcium, and then chlorine.
Bingo. Anybody have questions about the ionization energy? If you think about it, ionization energy and electronegativity are the same. They increase going up and they increase going left to right. Now, we have the atomic radius. It gets smaller going left to right. It gets smaller going from the bottom to the top. Going from the bottom to the top makes perfect sense because every time you put a new period, every time you go down a row, you've put another orbital. You put another orbital, you've made the atom bigger. So the ones at the bottom are going to be bigger than the ones at the top. Now, it takes a little bit of thinking for the other ones, but if you think about it, it makes perfect sense. Okay? Katie, I'm going to pose the same question that I posed to Rosina. Let's look at fluorine. Okay?
Okay.
Fluorine has 9 bullies that are trying to pull that electron in. That's what we're talking about. We're trying to pull the electrons in closer to the nucleus. So, Katie, you have 9 bullies that are trying to pull you down the street, as opposed to lithium that has 3. Which ones are going to be more successful at pulling you down the street?
The fluorine bullies.
The fluorine bullies, because there are more of them.
Yes.
So fluorine has more protons. It's able to suck those outer electrons in closer. If it sucks them in closer, this makes that whole atom smaller.
Okay.
So atomic radius going left to right gets smaller. Going bottom to top gets smaller.
So if it was just like one of the where it says the bottom left FR, which is francium, and then helium is the smallest. So if it was just like one of each, the francium would have the stronger pull because it's larger. Like if you were to say it like in the bully analogy like you were using. So if it was one bully of francium and one bully of helium.
Okay, let me ask you this question. Let me ask this question. You got 2 bullies right next to you trying to drag you down the street, okay? They're able to grab onto your arm and pull you, right?
Right.
And you got 87 bullies that are half a city away that have ropes attached to you. How successful are they going to be at pulling you away?
Well, I mean, if it's 87 of them, probably more successful than the one guy.
But they're only tangentially pulling you. They're so far away that you don't feel the force. Let me see if I can come up with another analogy here.
No, I understand. So since it's larger, since the nucleus, or not nucleus, whatever, the protons and the neutrons, since it's farther away because of all the layers, it has a weaker pull.
Right. Absolutely.
All right, I understand. So
Absolutely.
the smaller ones have a stronger pull then.
Yes.
Okay,
On the
gotcha.
valence electrons. Okay. So right now we're just concentrating on size. Atomic radius, left to right gets smaller. Atomic radius, bottom to top, gets smaller. So we got fluorine, chlorine, and iodine. Gaith. Gaith, you don't have a periodic table, do you? Or do you?
I'm having some issues, Professor. I apologize.
Okay. Terry. Terry, you out there?
Unfortunately, yes.
Okay. Fluorine, chlorine, and iodine. I want you to list them smallest to largest.
Iodine, chlorine, and fluorine.
Smallest to largest.
Wouldn't it
Okay.
go from the bottom?
Remember, I said it gets smaller. The smallest is at the top, the largest is at the bottom.
Oh, so it's fluorine, chlorine, then iodine.
Yes. Fabiana? Fabiana?
I'm here.
Do you have a periodic table?
Yeah.
All right. Sulfur, aluminum, and sodium. Sulfur's one below oxygen. Aluminum should be in that vicinity.
So sodium will go first, and then aluminum will go second, and then sulfur.
Is she right? Going from
Is it from
smallest?
largest to smallest?
No, it's smallest to largest.
Oh, I'm sorry. I thought it was like the opposite. Okay, so it's sulfur, aluminum, and then sodium.
Because sulfur has more protons, it's going to have the sulfur, because it has the most protons, it's going to be the smallest.
Yeah, I thought it was like from largest to smaller for some reason, so my bad.
Okay, chlorine, sodium, and iodine. Lewis, I haven't talked to you yet.
I'm here.
Lewis,
Yes, sir.
do you have a periodic table?
I do.
Chlorine, sodium, and iodine.
Okay. It would be chlorine, sodium. Okay, so it would be chlorine, and then chlorine first, and then it'd be, is it iodine and then sodium?
Other way around. When you're making a choice, between up and down and side to side, the up to down takes preference. Okay, Lewis, by that I mean the fact that iodine is 2 periods below chlorine, that has a greater effect than sodium being all the way to the left. It's a good question. Good point out, Lewis.
Okay, so then it would be.
All right. All right, let me try and illustrate this. All right. When we have chlorine, we have the first orbital has 2, second 8, the last orbital, the third one has 17. It's in the third orbital. Now, sodium also has a third orbital, but there's only 1 proton in it. Okay. Now, when we consider iodine, iodine goes out to a 4th and then a 5th orbital. So this is 2 orbitals beyond where the chlorine sodium are. The impact of going up and down has a greater effect on size than going from left to right. So chlorine is the smallest. Sodium is next. Iodine comes third. I'm going to try the last one, Lewis.
Okay. So it would be, is it nitrogen?
Nitrogen, fluorine, and antimony.
Okay. Okay. So would
Stretch it out, Terry.
Would it be fluorine, antimony, and then nitrogen?
Again, remember I said up and down is a greater effect than side to side. All right, let me ask you this question, Lewis. Let's break this down one by one. You already agreed that fluorine is smaller than nitrogen, right?
Yes.
Okay, so is nitrogen smaller or greater than antimony? Between nitrogen and antimony, which one is smaller?
Nitrogen.
So nitrogen is smaller than fluorine, and I'm sorry, nitrogen is larger than fluorine, but it is smaller than antimony.
Okay. Okay. Makes sense. Okay.
All right.
Yeah. Got it.
All right. Guys, I do have a homework. I do have an extra homework in there that deals specifically with this issue. I would definitely look at it, okay? Definitely look at it and practice it. They're simple. Basically, it's just looking at questions just like that. It'll give you 3 elements and it asks you put them in order. Actually, I think I put it for 5, but it tells you to put them in order from biggest to smallest, from highest electronegativity to lowest, things of that nature. I would really encourage you to go ahead and look at them. Okay? Questions on periodic trends, guys? Anything? Hearing crickets? I'm going to go on.
Professor, can you go over the atomic radius again? Because I am totally confused. I was with you until everything else, but with atomic radius, I'm lost.
All right, let me get the share screen. I think that is dope. Hunter.
Hunter, dope is bad for you, man.
Hunter.
Hello?
Yeah, you're verging on inappropriate here, okay, Hunter?
No, it's a term. I think that is cool. I think that is positive.
All right. I'm sorry, I'm an old fart. I don't know new terms.
Yeah, no dope. There's no dope.
Remember, I'm from the groovy age.
All right. No, does not mean.
All right, no problem.
Yeah, he wasn't talking about dope, sir.
No problem.
I'm not a doper.
So, all right, Rosina, are you seeing the screen again?
Yes.
All right. Now, let's go to current slide and.
So I understand that for, say, francium, the last electron is furthest away from the nucleus compared to, say, hydrogen. So that is why the radius of francium is going to be much larger than that of hydrogen. But then moving from left to right, that's where I'm thrown off.
Okay. I'm trying to,
Because the atomic
I'm
numbers
trying to
are
come up with
increasing,
a-
and that's where I'm confused.
the atomic numbers are increasing, absolutely. What does that mean about the number of protons, Rosina?
Increasing.
Okay. All right. Say you have one negative magnet that is 5 inches away from one positive magnet. Okay.
Mm-hmm.
That has a certain force, right?
Mm-hmm.
Now, if I keep that one negative magnet 5 centimeters away, and instead of one magnet, I put 3 magnets 5 centimeters away. Which
The
one
pull is going to be
pull?
harder.
I'm sorry?
The pull with the 3 magnets is going to be harder.
If it's going to pull harder, is it going to be able to pull it in towards it more?
Yeah.
So fluorine has 9 magnets.
Mm-hmm.
Lithium has 3.
Yes.
So because fluorine has 9 magnets, it has more force. It can pull the electrons in closer. If the electrons get pulled in closer, it makes the atom smaller.
Oh, got it. Okay. All right. Thank you.
And actually, I thank you too, because that's kind of, I've got a new slideshow and it doesn't make sense for me to try and start that right now. Anybody have any other questions over what we've gone over tonight? We've gone through periodic trends and we finished up valence. What we have to do yet is, I got to look at, I have misplaced my thing. There it is. Sorry, took me a while to get it, but I did get it. All right. So today is what? The 28th? Today is the 28th. I'm looking at the schedule. We were supposed to be through energy and calorimetry today, but not a big deal, because on next Tuesday, it was supposed to be an instructor day anyway. So we will get through energy and calorimetry on Tuesday, as well as counting atoms. That will all be done on Tuesday. We will get through that. We have a test, our first test, next Thursday.
I have a quick question about that test.
Okay.
Is honor lock going to be on that?
Yep.
Okay.
I hate it too. I hate it just as much. Think about it this way. Who do you think is sitting there at the phone answering your calls, trying to get you hooked into honor lock?
I have a question. Is
Believe
it
me,
going to be multiple choice?
No. It's not going to be multiple choice. And Hunter, you ought to thank God for that, because I give partial credit. If it's multiple choice, you either got it right or you got it wrong.
Yeah.
No gray area. But if I give you partial credit, this means that I can give you a little bit because you knew the first step or two of the problem, but you didn't know the last part of it. Or you knew how to do the end, but you didn't know the first part.
What day is the test? What day is the test?
Next Thursday, I believe it's the 4th.
And is it the like time of our duration of our class, or is it a different time? Since it's honor lock, is there like a specific time we have to take it?
What I generally do is I leave it open from 8 until 7 o'clock.
8 to 7 o'clock. Okay.
So beside periodic table, what else can you bring with us?
Sorry, 1 second, Rosina. Is there anybody that cannot make that time?
Like 8 a.m. to 7 p.m.? Okay.
Yeah, this is Jennifer. I work until 5 and I get home at like 5:15. Do you know
Is
how
that the
long
same, Professor?
approximately the test like takes to do it? Or I work from 8 to 5 and I work about 15-20 minutes away.
Jennifer, if I leave it open till 8, would that give you enough time?
Yeah.
There you
Professor,
go. Done deal.
Okay, thank you.
Rosina was, I'm sorry, Rosina was next.
Yeah, so beside the periodic table, what else can we bring with us?
The kitchen sink.
For real?
If
So we
it's
can bring our
if it's transportable, you can bring it.
So notes are allowed then. Okay, thank you.
Yeah, you can bring a file cabinet. You can bring a file cabinet with everything in it.
But
What
we
you're
can't
not
use
allowed to
another
do,
browser.
you're not allowed to use another browser, and you're not allowed to use your phone. And obviously, you're not allowed to have anybody in there in the room with you.
Can we use the calculator on our computer though?
No.
Okay.
No, Victoria, I'm sorry.
No calculator?
No, that's not what I said.
No, or calculator. Yeah, okay.
No calculator that's on your computer. You have to have a separate calculator.
Okay.
Okay.
What kind of calculator is allowed? Like I have a TI-84 Plus. Like,
okay.
Is there a certain kind of calculator that we're allowed to use?
Does that mean something to you?
Well, I had to get it for calculus.
Okay. It's a programmable calculator, isn't it?
Yes.
If you're smart enough to figure out how to program it, then you're smart enough to use it.
All right.
I wish my math teacher said that.
What's that?
Program all the formulas in
I wish my math teacher said that.
You and me both.
Hey, I mean, honestly, what's the difference between you having it in a computer, right? Or am I allowing you to have it on a piece of paper? You tell me what the difference is. You still got to know which formula to use, right?
See, Professor, I just have some couple of questions because my connection was going out. So because the same thing, I work on Thursday, I get off at like 5:30. So how many questions is the test? And it's all gonna be written. There's no multiple choice, you said, right? I'm just trying to recap.
I'm not going to say, I'll be honest with you. I will be able to answer those questions better on Tuesday because I haven't looked at the test since September of last year. Okay. What I'm going to do is I'm going to look at the test on Sunday and I will go through it on Sunday to make sure that it's has all the pertinent information it needs to. So ask those questions on Tuesday. All right.
Okay, so there will be like a visible representation for the test, correct?
There's a what? A what? Why do I feel like I'm in My Cousin Vinny and I just said Utes? Obviously, that's
what?
Oh, I love that movie.
It's a great movie.
It's Gate, right? Gate's talking. Gate, I didn't understand your question.
I think he died, Professor. It's okay. We can move on.
Anything else, ladies and gentlemen?
No. What was Gates saying though? Like I think he was asking for something.
He said his internet was cutting in and out, but I think he was just talking about him getting off of work late or something.
He was asking about the types of questions.
Okay.
Mom.
I mean, for that sakes, guys, I don't mind even holding it out to 9 o'clock. I'm not that.
Yeah. Because I'm like them. I don't get home
half the night. I'm going to be up half the night grading these things anyway. So.
Do we not have class that day? We don't have class on Thursday, like test days? Okay.
You're not going to have class on test days.
And so
unless you want it, Christina, are you making a suggestion?
No, dear God, no, please. If I could have just an hour out of a class, that would be so awesome. For the quiz 5 on Tuesday, that's going to go over the energy and then also the valence electrons, periodic table, and trends.
Yes.
Okay.
What happened was I got behind, and because I got behind, I just thought it would be a better idea to have it at that time. Okay.
Oh, please. Yeah, that works for me for sure. Thank you.
I'm not sure if you answered this already. Is the test going to be timed on honor lock?
Yes. Yes, and I think I give you, at least 2 hours.
2 hours.
Hold on a second. I gotta think. I'm gonna stop share. Now I gotta get back here. Nope. Nope, I'm sorry, I'm out. I guess I can, let me look. Okay, this is what I want. That's what I want. Guys, we're breaking in, we're getting into the lab time here, so I'm gonna have to cut this short, definitely by 7 o'clock.
I got one last real quick question.
Real quick
on the
question,
test
go
day,
for it.
because I know you said we don't have class on the test day, but will we still have lab or will that be gone too?
You will have lab.
Okay, perfect. All right,
So,
thank you.
so if you are working, Jennifer, you still there? Gaith, are you still? Jennifer,
I'm still here.
all right, Gaith, you're here?
Yes.
All right, I will be able to arrange something where I give it to you early. Remind me on Tuesday, please.
Yes, sir. Thank you.
Okay.
So can
Jennifer, the reason I have to give it early is I really do have to stop the time at 7 o'clock since I have lab that night.
So can we tell you on Tuesday that, because I also work and I get home at 5, so.
Yeah.
Okay.
Anybody that has a scheduling conflict. Anybody with a scheduling conflict, tell me on Tuesday.
Got it.
Okay. Mila asked a question.
Yeah, just about the time limit on it. I don't know, dude.
Okay.
I think he said 2 hours.
He's looking it up right now to confirm.
Oh, crap. Huh. I got to write the damn test. It's already written, but I got to write it. All right. Let me see what I did somewhere else. Generally speaking, when I give tests, I give very long tests, ladies and gentlemen. That's good and it's bad, because if I give long tests, that means you won't have studied something in vain. Okay, let's see what I have here.
Is it all right if I leave?
Yeah.
I gotta do. Okay.
Yeah,
I
yeah,
just
yeah,
wanted to make sure
absolutely.
I'm part of the attendance. I need to
No,
do
no,
something
I'm-
before the lab starts. So. All right, but thank you.
Who
Everyone
are
have
you?
a good
Who
night.
are you, by the way?
Alec Root.
Okay, gotcha, Alec.
All right, you have a good night.
You have a good
Or
night
wait,
too.
I'm gonna see you. Never mind. I'm gonna see you in lab.
All right, I'll see you in lab.
Professor,
One second, I'm trying to answer Mila's question.
Okay.
Is Spencer out there by any chance, Let?
I
All
think
right.
he was here.
I have the time limit set for 2.5 hours. Okay?
Okay, thank you. I just want to make sure with the kids and stuff.
I don't think you're gonna need 2.5 hours, but well, for that matter, it only took me 30 minutes to do the test with the answer sheet.
Darn it. Can we have the answer sheet, sir?
Certainly. What time on the 5th of February would you like the answer sheet? Anything else, ladies and gentlemen?
I think
A
that's
visual
it. We'll see
representation
you
of the test.
Thursday. Or in lab.
Have a good day, Professor.
Have a good day.
Bye.
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 All right, sir.
Bye.
Professor.
Bye. Have a good night.
Bye. I'll see some of you later.